Okay, there's a little bit of a story here. And the story was I really just wanted to work on a product made by NAD. I've seen many videos and I've heard great things about them. I just never had worked on them. They're not flashy. They're not a Marantz. They're not, one of the higher end Pioneers or even the Kenwoods or any of the other, common ones you see on YouTube most of the time. But I did find this NAD on the top. It's a NAD 906 multi-channel amplifier. And so I ordered it. It was like $20, or with shipping, it was like $40. So it arrived, and it arrived demolished, completely destroyed. You can see the corners just broken in, and the case is bent, and this side's bent out. I just sent the seller a note saying, hey, this is completely destroyed. Now, not only can I not fix it, there's no reason to fix it. It's destroyed. No one will buy it with destroyed, so I just want to return it. He said, just keep it. I'm like, okay, fine, parts, I guess. So then I get back on YouTube and I look for another NAD 906, and I could not find one. But I could find an NAD 916 that I believe is mostly usable. I think one of the channels may have an issue. It's missing the power button, but that's not a big deal because I have a power button here. So I can just take this, take the parts out of this one if I need any and use them in here. I think these are pretty much the same. This one has a little bit higher specs, I believe. I'll have to look it up to see exactly. This one is clearly larger. The 916 is clearly larger than the 906 in both width and depth. It's a little bit deeper and just slightly wider. Anyway, what I'm going to do is I'm not even going to look at this. I haven't plugged it in, don't care, not going to look at it unless I need a part out of it. So what I'm going to do is I'm going to hook this up to the dim bulb, see if there are any shorts. Then I'm going to check the speaker terminals for some DC offset, see if we have any problems there. And then we'll just move forward and pop the case off and take a look inside. Dim bulb tester's on. Right, we've got 31.3 watts roughly. Green light. I'll just take it off the leash. No problem there. 38 watts, drawing about 0.45 amps, somewhere in there. No smoke, no problems. So now let's check the DC offset. Okay, channel 1. We have like 42 millivolts there. Channel 2, 46 millivolts there. Channel 3, 31 and change. Channel 4, 42. Channel 5, 45. And channel 6, 48. I have not looked at the specifications. Those seem a little high to me, but they're not unreasonable. I'm going to hook up some speakers to channel 1 and 2 and then put an input signal in and just see what we get. Okay, so we're going to pipe the output of the amplifier into the SIN core. I'm only going to use one channel. It's going to be on the left channel. So just keep your eye on this meter. And we're going to start with channel 1. And we are running 250 millivolts of a sine wave of 1 kilohertz into channel 1 right now. And you can hear nothing. You see nothing, you hear nothing. Let's move over to channel 2. Nothing good there. Maybe? No? Let's check channel 3. something happened with the amp. I've blown a fuse somewhere, and I think it might be in the dim bulb tester, because the dim bulb tester is off and it's in bypass, so we've blown something on the dim bulb tester. Still nothing on channel 1. We do have a signal on channel 2, and as you can see, it's complaining about DC offset on this channel, and so it doesn't like that. Let's go to channel 3. That one seems to be okay. Go to channel 4. Channel 4 looks good. It does still complain about the DC offset on channel 4. Go see what we get on channel 5. Channel 5 and 6. Nothing. Nothing on channel 5. Nothing on channel 6. So channel 5 and 6 don't seem to be good. I mean, just to make sure, I'm pretty sure these are tied together. 5 and 6, 3 and 4, and 1 and 2 are tied together, but they're all independent. So yeah, we've got a few problems we need to look into. All right, I popped the screws out of this. Let's take the top off and see if she's as pretty on the inside as I hope. All right, very cool, interesting. Let's take a look. Let me move the camera. What I think we're looking at here is 3 independent, exact duplicate amplifiers. So you have a transformer, power supply, amplifier, transformer, power supply, amplifier, transformer, power supply, amplifier. Okay, pretty straightforward. It looks like they are easily removable from the chassis. There are only 2 wires that I can see so far on the top, going to each, maybe 3 wires. 3 wires going to each of the amplifier boards, and we have control ribbon cables here, and then we've clearly got output to the speaker terminals. So what I think I want to do is flip it over and see if the bottom plate is removable, which I'm pretty sure it is, and if so, if taking it off, how flimsy it will make this case, because it doesn't look like there's a lot of support other than the bottom plate, but it may be fine. So let's flip it over and remove that case. All right, I'm not exactly sure which screws to remove. I'm going to start with the ones on the exterior and see what we can get away with. All right, so we have a couple of cross braces, which is good. Looks like in order to remove each one of these amplifier modules, or each module, there are only 2 screws holding them to the heatsink, so it'd be interesting if those Are they really only 2 holding them in there? Anyway, I might not need to remove them, but I probably will. I'm just going to do a visual inspection at this point and see if I can notice anything visibly wrong, such as bulging capacitors or fried resistors, things of that nature. Okay, you can see someone's definitely been in here before, and I suspected that earlier because the emitter resistors look like someone just put them in there in such a hurry that they were going to catch a plane or something. But you look right here, you can see there's a lifted trace right there. And if you look on the other side, where that was, you can see here we've got this big fat solder bridge here. So that's definitely not factory. All right, this board where my index finger is channel 5 and 6. This over here is channel 3 and 4. Now, what I want you to look at is this down here and down here. If you see this fuse and this fuse holder, this looks normal. This one does not. You can see it. There's a smaller fuse just sitting in there, and the fuse holder itself is broken. And that little thing's just barely sitting in there. See if we can just pop it out. Yes, it's barely sitting in there. I'll get my fat fingers in there. Okay. Nothing wrong with the fuse per se. But you can see the fuse holder is bent. And sort of broken. I may have to replace that. There's no springiness left in it. It's just bent and worn out. Yeah, that's less than ideal, but not necessarily a cause of a failure. Also, if you look down in here, maybe you can see it. If you look, and keep in mind, nothing's plugged in. This is not plugged in. I'm just pointing and showing you where stuff is, so let me get something that's more appropriate. If you look right down here, under here, you can see all this conductive glue. It may or may not be conductive, but it's glue nonetheless, and it is covering several of the components, including these here, which I can't even see. And it's on this board, and it's on the other board for 1 and 2. And it's apparently covering a diode and maybe a resistor. Can't tell from this angle. Let's see if we can add some more light. So there. Now you can see that brown stuff. See if I can snake that around. See that? That's not good. Not necessarily a major problem. What's this thing? Don't know what that is. Don't know where that came from. So, I mean, nothing seems to be burned as far as I can tell. Kind of hard to see everywhere. And from the fact that several of the channels were working, there may not be anything major in here that's wrong, hopefully. I don't see anything major. It's just dirty. It looks like it's been kept in a storage building, uncovered and unwrapped, because there's just lots of dust and dirt everywhere. Okay, before I start doing surgery on this amplifier, I'm going at least to attempt to try and adjust the idle currents on each one of the amplifiers. And the instructions for that are to connect a voltmeter, digital multimeter across P401 and P403 and adjust VR, variable resistor 447, for a reading of 5 millivolts plus or minus a half millivolt DC without a load across the output terminals. Then you're going to repeat that step using 0.402 and 0.404 and adjusting VR 448. So the first thing we're going to do is the first part. So I'm going to turn it on now. See where we are. All right, we're at 4.2, and that's not far off. It's almost within spec. I turned it on a minute ago and I actually was looking for a tool to find, and I accidentally moved the pot and it was at 3 point something, so we're actually moving it in the right direction. So I'm going to adjust this a little bit more to the right. And we're going the wrong direction. Back to the left. .02. I'll take that all day long. And I just turned it on, so it hasn't had any time to warm up. But it doesn't seem to be drifting at all right now, but we'll let it warm up. So now I'm going to move the wires to the opposite side and do the other right now. Okay, we're on the other side. We are on pins 402 and 404. And we're going to turn the amplifier back on. All right, this one's closer than the other one. So 4.78. Technically we're on spec, but I want to get it closer if I can. So the other one was at 5. And I went the wrong way again, of course. .97. Whoop. Too far. 5.03. I'll take that. Okay, we're now on channel 3 and channel 4, the middle amplifier module. And we're going to adjust the balance trim pot, or the idle current trim pot right here. So I'm going to turn the unit back on. And we're at 4.5. Let's see how badly we can mess this up. Oh, how about we use the right end of the screwdriver? It's not a screwdriver, but you know what I mean. Okay. 4.7. 5.01. I quit. Next adjustment. It's somewhere in there. So we're going to adjust, we're going to use that point and then this point over here. Okay. Nothing shorted out. I think you can see the meter from there fairly well. Okay, let's turn it back on. And we're at 3.7. The reason it's negative is just because I just flipped the polarity around the wrong way. Not a big deal. We're still going to adjust for 5. So we're at 3.8. We want 5. Let's go to the left. And of course I go the wrong way. Go to the right. I'm literally breathing on this thing and it's moving. .04, 5.05. That's good enough. All right, let's move on to channel 1 and 2. All right, this one's going to be a little bit harder to get to. Maybe a little bit. Let's turn it on. Okay, we're at 5.1. I almost don't want to mess with that. That might be close enough. Let's see if I can adjust it closer to 5. Or if I'm just going to mess it up. Yeah, I'm literally just wiggling it. It's not. I'm going to take 5.1 is good. Okay, I jumped ahead without you because I wasn't really sure what I wanted to do, and I wanted to formulate a game plan to figure out how the easiest way to work on these amplifier boards would be. Whether it was to disconnect all these wires, whether it was to cut the wires and put connectors in, so on and so forth. So I believe the easiest way is to undo all the screws on each module in the back of the amplifier. Then those boards will just pull straight out through the back panel, and then they can just hang wherever you want them to. And then on the bottom side of the amplifier, there are the 2 screws that you saw already. Those 2 screws will let the amplifier go, except for there are 2 plastic standoffs, and you can see one right here. Right there, there's one over there, and then there's one back here. And those go through the board themselves. There's a hole in the board. So once you pinch those retainer clips, then the board will come straight out. And I believe that's going to be the easiest way to work on the board without taking any wires completely off the board. Well, the other night, I could not figure out what was going wrong with channel 1. It wasn't working, and everything looked fine. There was no visual problems. So I pulled out the output transistors here, the PNP and the NPN transistor, and tested them. And they were fine. I'm not really sure about this gain, but I think it's fine. They got 82 gain out of the PNP and 32 out of the NPN. I did not pull the other 2 on the second channel because this channel was working fine. So eventually I tracked it down to a capacitor that was right here. That was a 22 microfarad at 16 volt capacitor, and it was completely shot. You could probably see some of the stuff coming out of the bottom of it, but this was dead. I only had a UKL series Nishikon of the same capacity. Clearly it's giant because it's 100 volt, and that was all I had. I didn't have anything quality lower voltage for 22 microfarads. So I have ordered some more of smaller voltage just so I'll have them in stock. But that fit just fine on there. It doesn't seem to be in the way of anything else. And that worked. Then I started testing everything, and it still didn't work. So today I said, okay, let's just take a step back. I plugged in the oscilloscope. I plugged in a signal generator to the input board, and this is the input board right here. And you can see it has, left and right inputs, or channel 1 input on the left and channel 2 input on the right. And so I basically just started tracing through the input board to see, are we getting signal out of the input board? And we were, and it was fine. And you can see here in the middle, right here in the middle, this white cord is channel 1, and this white cord is channel 2. And so we got signal to this channel. And so then I just started tracing all the way through the board. And then I got to the end, and I'm like, okay, let's work from the backside. Let's work from the output transistors toward the input. And when I flipped it over, I found out that I had not soldered the emitter and the emitter and the base legs for both of the output transistors. I guess I was just really tired. Dumbass! The other night, and I said, okay, I'm taking a break. And I forgot to solder those back in. So when I soldered those back in, the board magically sprang to life, and everything is working fine so far. Let's look at the analysis on the Panasonic now. As you can see, we are putting out a 100 millivolt sine wave into, basically each channel. And we're looking at the total harmonic distortion right now. And you can see both channels are putting out right at 1 watt. Now, I believe this receiver says that it will put out 1 watt at 150 millivolts. So it's putting out more than is expected. And the THD is very good. If you look at the THD plus N and the harmonics, I mean, it's excellent. So I've never tested an NAD receiver before, but this has got to be one of the lowest distortion amplifiers I've ever tested. And it sounds great. So let's move on to the other channels. Okay, here's what we're working with. This is the channel 5 and 6 board. and I have replaced two capacitors that were both open. The first channel has the exact same problem, so I'm assuming that almost all of these capacitors in that one spot, which is C401 right here, well, you can't really see it, but it's down in here, they've all just gone open and they're just completely dead. So I've replaced each of those and then tested the board right after replacing those, and they all work perfectly. What I have left to do with this board is to fix the fuse holder. So I've ordered a replacement through-hole fuse holder mounts for that. Those will come in tomorrow. I'll get that fixed. I'm going to go ahead and replace the rest of the electrolytic capacitors in here because they're all the same brand as the ones that were gone out, and there are like 3 more that are in the audio path. Let's take a look at the Panasonic audio analyzer for channel 5 and 6. Now, as I previously mentioned, that the service manual said that the amplifier should put out 1 watt at 150 millivolts. That was incorrect. It should be 185 millivolts of input should result in 1 watt of output. As you can see on the screen here at the top, we are sending in a signal at 185 millivolts, and I have adjusted the inputs on the back of the amplifier to be set at 1 watt. Now, the user could turn around and just turn the input signal all the way up to the right, clockwise, which effectively reduces the potentiometer to just 0 ohms of resistance. So, you know what? I'll go ahead and demonstrate that. So, I'm not going to show you, but watch the screen, and I'm going to turn the potentiometer for one of the channels. I think this is the one on the bottom, I think. I'm going to turn it to the right. See how much it went up? So now watch, I'm just going to turn it all the way to the right. And now we're like at 3.66 watts. So if, you know, when I go to sell this, I'm going to set it so that it is down at 1 watt. And I'm going to leave a note to say, hey, here's where you should probably run it, but if you want to run it somewhere else, you can. But I'll probably put a little bit of red paint to indicate where it should be set, and just make sure that both channels are set according to specifications. But I mean, it's their unit, right? So when they buy it, they can do whatever they want to with it. So as you can see, at 1 watt, we are looking really good at almost 0.003, a little below that, of distortion. Let's see if we can get any kind of harmonic information out. Yeah, this amplifier is super clean. All right, I just finished replacing the fuse holders, or the fuse clips that were in here before. They are right here, and you can see they just break and fall apart. They were very brittle. I'm going to go ahead and replace the rest of the electrolytics. I've tested the other fuse clips that are on the other boards, and they all seem to be fine. I don't know why these had issues, but anyway, those are in. I'm going to replace the rest of the electrolytics on this board. Those consist of these two here. There are 2 on the other side of the board. And then this one here, that's a 220. These are 22s. And so I'm going to replace these 3 and the other 3 on the other side of the board. And then I have decided to also pull out channel 1 and 2 again and replace the mica pads that are on channel 2. Actually, I take that back. I'm going to pull out channel 3 and 4. I did not pull out that board, but I have replaced channel 1 and 2 and 5 and 6 using these sill pads. So to be consistent across all the boards, I'm going to replace these 4 electrolytics on every channel, as well as the mica pad, insulating pads on every channel for all 3 boards. And I'll just go ahead and do that now. I just want to make sure that everything is done comprehensively, and the owner of this amplifier will be happy for years to come.
Okay, what I'm doing here is just showing you me replacing a capacitor. I'm not trying to get these solder joints perfect at this point. I'm just trying to get a little bit of solder on the leads. And then my index finger of my left hand is on the other side of the board, trying to push the capacitor through so that it sits flat on the board. And now that's it. It's good.
Okay, I said I was going to replace 4 capacitors on each side. That would be 1, 2, 3, and 4. However, I did not see an electrolytic that was over here, which was a 1 microfarad, so I just replaced that with a WEMA film cap. So we have the 222s here. We have a 220 here. I think this is a 220 also. And then the same on the other side. So after replacing all of those, let's take a look at the performance. All right, we are looking at each channel, which is channel 5 and 6. 5 is on the top, 6 is on the bottom. I have adjusted the inputs to output roughly 1 watt at 185 millivolts of input. And our noise is looking pretty fantastic. I turn the harmonics off. We just look at plain distortion. There we go. And we're getting 0.001, 0.002. Maybe a little bit more distortion on channel 5 than channel 6. But you're splitting a 1,000th of a percent. So I'd say that's pretty decent by just replacing a few capacitors and nothing else. We didn't replace any diodes, any other film caps, any other resistors, just a few capacitors, and it's back up and running like a champ. Next up, we'll just take out board 2, which is channels 3 and 4, and replace those mica insulators and the same capacitors replaced on board 3. I just finished putting channel 5 and 6 back into the chassis, and I was about to pull out channel 3 and 4, but before I wanted to do that, I wanted to run a little performance test on it just to see how it was going to behave before and after I replaced the capacitors. However, if you look at the top readout here, look at the top one, you can see that we have half a watt, a little bit more than half a watt. But the potentiometer, the input potentiometer on the back of the receiver is fully rotated clockwise. If you look at the bottom one, this one's set to 1 watt. Now watch what happens when I rotate this channel's potentiometer all the way to the right. So we're getting about a little more than 3.5 watts out of 185 millivolt input. This one is capped out at a little over half a watt. I cannot get any more out of it. Therefore, there's got to be something wrong with the output transistors or something. Could be a driver. Something's wrong with this channel where I'm not getting the output I should. So I'm going to have to do some more testing on the output transistors and the transistors on channel 3 to see what's going on there. Okay, this is the board for channel 3 and 4 before I've done any modifications to it. You can see it's a little dirty, not too bad, but look at the resistors, the emitter resistors, the white squares. You can see they're just kind of haphazardly thrown in there, turned sideways. Yep, here, and here. They're just not cleanly put in there. You can also see these have the mica insulators. I'm going to pull all these out and replace them with the sill pads. And then per usual, we're going to replace the the capacitors in here, all of these electrolytics. They're like two 220s and two 22s. And then the one on the end here is a 1 microfarad. And we're going to do the same to the other side. Another thing we're going to do is get rid of all this corroded glue down there on the inside. And then we're going to clean everything back up. If you look at channel 5 and 6, you can see that's what we've already done to channel 5 and 6. And it's clean and working well. Okay, this looks exactly like the amplifier that I have been working on, but it's not. This is the 906, not the 916. But the service manual for the 906 and the 916 are the same document. And just looking at everything, they look to be identical. Now, this is my parts, or my donor amplifier, and I have 3 of them, and they are great, except they were damaged severely in shipping. So that means I have a lot of output transistors, driver transistors, other things that I could use on the 916. I notice these have different, inductors have different coatings on them. The other ones seem to have a black coating. These have blue. The capacitors are blue, not black, so that's a different brand or a different series, whatever, but the output transistors are exactly the same. The terminals on the back are a lower quality. You can see the board here was completely cracked in shipping. The front was completely demolished. So it's this is trash. So what I'm going to do is I'm going to steal the power button and the power light out of here and then put it in the 916. While we're doing a comparison, this is the faceplate for the 906. This is the faceplate for the 916. While they look very similar, they are completely different. Listen to this. You see how light and flimsy that is? This is very heavy-duty aluminum. This is very lightweight plastic. So maybe the 906 cut corners, I don't know. But that's a big downgrade. The power button has been liberated from its sister unit. And so let's see if the power light also comes on now. I did not take the power light out of the sister unit like I said I was going to, because I checked the voltages in the sister unit, and then I checked the voltages in this unit, and this one was not, it did not have the correct voltages where it should have. So I tracked that down to another fuse, replaced that fuse, and now we'll see if this light comes on. Power on. Bueno. Good news. On to the performance tests of each of the 6 channels now. All right, this is channel 1 and channel 2. Channel 1 is on the top, channel 2 is on the bottom. We are driving 500 millivolts into the inputs, and you can see our THD is looking really good. Keep in mind, this amplifier is rated for 30 watts into 8 ohms, no more than 0.04% total harmonic distortion, and we are clearly very far below that. I think we can probably get up around 1.2 volts input, maybe 1.25, somewhere in there before we start clipping. Let's check it out. Let's put in 1.2 volts. And now we're getting 42 watts, well above where we should be clipping, right? Well above specifications. So that's excellent. Let's go Go back to 500 millivolts. And we will switch to channel 3 and 4. One thing I forgot to mention is that I let the amplifier warm up for well over an hour, and then I reset the idle current to 5 millivolts for each channel of each amplifier before doing these tests. So here we are on channel 3 and channel 4. Excellent results here. Let's try and go up to, let's say, 1.2 volts again. And you can see now we're starting to clip on channel 4. So let's go down a little bit, down to about 1 volt. See if that cleans it up. Yeah, now we're just below specifications at 1 volt. And that's where the service manual says specifications should be. 30 watts output given with less than 0.04 THD. So this one, not as good as channel 1 and 2, but still up to specifications. Let's switch to channel 5 and 6. Okay, here we are, channel 5 and 6 at 500 millivolts of input, and just like the others, very low distortion. So let's go up to 1 volt of input. With 1 volt of input, we are about 30 watts, well below distortion specifications. Let's put in 1.1 volts. Now we're getting 35-ish average on both channels. And let's see if we go up to 1.2. And 1.2, we're over 40 watts per channel at an order of magnitude lower on the total harmonic distortion. So all 6 channels of this amplifier are performing better than specifications or well beyond specifications. So very impressed. It's a clean amp. If you're just now getting into amplifier servicing, NAD amplifiers are very easy to work on. They are straightforward, they're clean. Highly recommend working on these as some of your first amplifiers. Solid state. If you're going to work on, early 1970s, take your pick. Marantz is easy. Pioneer is somewhat easy. So anyway, let's wrap this up. Here's the inside. Beautiful blue boards. Everything's perfectly laid out. Everything makes sense. If you understand one of these, you understand all of them. There's no complications in this whatsoever. Very nice.